Chapter 2-3, Conditional Statements. In the last section, we looked at joining two statements with the words or and. So it is blue or it's green. It's blue and it's green. And we looked at the truth values of joining statements like that. Now we're going to look at joining two statements with the word if, then. So if it is raining, then it is wet. It doesn't have to be in that order. We could say it's wet if it is raining. It doesn't matter which order we put it in. It really matters what words follow the word if. The word that follows the word if is the hypothesis, and the word that follows the word then is the conclusion. The notation we use for this is P implies Q, or if P happens, then Q happens. If a polygon has 6 sides, then it is a hexagon. In this statement, a polygon has 6 sides is the hypothesis. It is a hexagon is the conclusion. Tamika will advance to the next level of play if she completes the maze in her computer game. The hypothesis is completes the maze in her computer game. That's what follows the word if. The conclusion is will advance to the next level of play. So that is the conclusion. If you are a baby, then you will cry. The hypothesis is you are a baby. The conclusion, you will cry. So you are a baby, you will cry, and the answer to that is B. To find the distance between 2 points, you can use the distance formula. So you want to find the distance. If you want to find those distance, then you use the distance formula. So it would be A. Now we're getting to the point where we're going to put statements into an if-then form. So on this one, we're given that measured distance is positive. We want to write it in an if-then form. So basically what we want to do is measure distance, and if we measure the distance, it's always going to be positive. So to write it in if-then, we would do if distance is measured, then it is positive. If distance is measured, then it is positive. A 5-sided polygon is a pentagon. So if a polygon has 5 sides, then it is a pentagon. If a polygon has 5 sides, then it is a pentagon. A polygon with 8 sides is an octagon. If a polygon has 8 sides, then it is an octagon. If you notice, it's the word is that will tell us whatever follows the word is the conclusion. An angle that measures 45 degrees is an acute angle. This part right here would be the conclusion. It follows the word is. So if an angle measures 45 degrees, then it is an acute angle. We've talked about a little bit about the truth values of conditional statements when we talked about saying if pigs fly, then I'll buy you $1 million car. That's a true statement because pigs can never fly. So looking at this, we checked last time that when we had two statements, they're either true or false. There's no maybes here. So we always had the setup of true, 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 false, false, true, or false, false. So our statement, if Tom finishes his homework, then he will clean his room. So we're going to look at first if we have true, Tom does finish his homework, and then after he finishes homework, he does clean his room. That's a true statement for the conditional because the hypothesis can actually happen. We're in that case scenario where Tom is finishing his homework. Then he actually cleaned his room. So we have a true conditional statement. The next one is Tom does finish his homework, but then he says, no way am I going to clean my room. So that makes the cleaning the room false. This is a false statement, a false if-then statement. The hypothesis is true and the conclusion is false. Then we get to the little things that are a little bending in our mind, but we're looking at a logical statement, a logical truth or false. So if Tom finishes his homework, which means it didn't happen, it never did happen, it never would happen, it doesn't really matter whether he cleaned his room or didn't clean his room. These are both true statements. And I know that's going to take a little while for that to make sense to you. So I would say to yourself that if something could never happen, the hypothesis could never happen. For example, if a rectangle has 4 obtuse angles, that can never happen. It doesn't matter what I say after that. That statement will always be true because it could never happen. So when pigs fly, you'll do something. That's a true statement because pigs will never fly. At least now, I understand. They will never fly. So a conditional is false only when the hypothesis is true and the conclusion is false. When a hypothesis is false, the conditional will always be true. So the way to think of that is when the hypothesis is false, it can never happen. If something can never happen, then the whole entire statement in terms of logic is true. And if you think about that, when somebody says something to you like a rectangle has an obtuse angle and you know that they don't have an obtuse angle, you would probably just question them. Do you know what you're talking about? You never ever say to them that's true or false. You just question them. So the way I want you to look at this is if it can never happen, the logical statement is true. So let's look at this example. Determine the truth value of the conditional statement. If true, explain your reasoning. If false, give a counterexample. If you subtract a whole number from another whole number, the result is also whole numbers. So one of the things we have to remember first is what is a whole number? A whole number are the positive integers, 1, 2, 3, 4, including 0. The natural numbers don't include 0. The integers includes the negative, -1, -2, -3, -4, and also 0, 1, 2, 3, and 4. But we're looking at whole numbers. So we're looking at subtraction 2. So let's choose two whole numbers, 7 and 3. So I do agree with you. If I did 7 minus 3, that gives me 4, which is another whole number. It does work in that scenario. But what if you flipped it and did 3 minus 7? That would give you -4, and this is not a whole number. So that's when it doesn't work, and this is our counterexample. We only need one counterexample to show that something's not true. So this statement is false. The hypothesis is true. We can subtract one whole number from another one, but the conclusion is false. It does not always give us a whole number. If last month was February, then this month is March. Well, March does follow February, so this is a true statement. When a rectangle has an obtuse angle, it is a parallelogram. Well, the hypothesis is a rectangle has an obtuse angle. Can this ever happen? What type of angles does a rectangle have? They have 4 right angles. So this can never happen. So the truth value of the statement is true by logic. I know that it's a false hypothesis, but the whole entire statement is true. So the way I want you to think about it is if the hypothesis can never happen, then it's a true statement. The product of whole numbers is greater than or equal to 0. So remember, we have 0, 1, 2, and so forth. So if I did 2 times 3, that would give me 6. So it's true there. If I had 0 times 4, that gives me 0, and it says greater than or equal to 0. So the answer is true. The counterexample here gave us -3 times 4 is -12. Well, -3 is not a whole number in the first place. If yesterday was Tuesday, then today's Monday. Well, we go Monday, Tuesday, Wednesday. So if yesterday was Tuesday, then today has to be Wednesday. If a triangle has 4 right angles, then it is a rectangle. Well, here's our hypothesis. A triangle has 4 right angles. First of all, how many angles does a triangle have? It has 3. At most, it can only have 1 right angle. So this can never happen. The hypothesis can never happen, so it's true. Now we're going to get into different ways to rearrange our if-then statement. We started out with our conditional, P implies Q. The converse is when we flip them. So if I say it is raining, then it is wet, as my conditional, my converse would be if it is wet, then it is raining. The inverse is by knotting both of our original statements. So not P implies not Q. So if it is not raining, then it is not wet. The contrapositive flips the knots. So if it is not raining, then it is not wet. Looking at the example, if I use that the measure of angle A is 35 degrees, then angle A is an acute angle. And that's a true statement. The converse would be, if angle A is an acute angle, then the measure of angle A is 35 degrees. Well, that's false, because if it's an acute angle, it could be 45 degrees, it can be 2 degrees, it could be 36 degrees. So that is a false statement. The inverse, I'm going to knot the original. So if the measure of angle A is not 35 degrees, then angle A is not an acute angle. Again, this is false because it could be 36 degrees, it could be 2 degrees, it could be 89 degrees. Now I'm going to flip the statement above. Not Q implies not P. If angle A is not an acute angle, the measure of angle A is not 35 degrees, which would be true because it either has to be right or it has to be obtuse. One thing I want you to notice is the truth value. The truth value of the converse and the inverse have to be the same. They don't always have to be false, but they do have to be the same. If the converse truth value is true, the inverse has to be true. And the same goes for these two, the conditional and the contrapositive. They have to have the same truth value. Now, all four truth values could be true. All four truth values could be false. It could be false, true, true, false. But these two here have to agree, and these two have to agree. Our first example that we're going to write the converse, the inverse, the contrapositive of is about bats. And I gave a little information here. Bats are not birds, they're mammals. They have modified hands and arms that serve as wings, and the only mammals that can fly. Now, flying squirrels can't fly, they glide, where bats can actually fly. So we want to write the conditional, the converse, and the contrapositive. So the conditional is, if an animal is a bat, then it can fly. And that is a true statement. If an animal is a bat, then it can fly. The converse is we're going to flip it around. If an animal can fly, then it is a bat. Well, this one is false because a bird can fly. It's not a mammal, but it is an animal, so this one's false, and our counter example would be a bird. The inverse would be that we would not both sides of the conditional. So if an animal is not a bat, then it cannot fly. So I knotted both sides. This one is false again, which the converse and the inverse have to have the same truth value. So that fits. We wrote it correctly. And our counterexample again is a bird. Now our contrapositive, we're going to turn it the other way around. So this would be the contrapositive. So if an animal cannot fly, then it is not a bat. And that would be true because a bat has to fly. Again, that fits the fact that our conditional and our contrapositive has to be the same truth value. Our converse and inverse has to be the same truth value. The statement we're going to look at this time is the sum of the measures of two complementary angles is 90 degrees. So to write the conditional, if two angles are complementary, then the sum of their measures is 90 degrees. And that's a true statement. The converse would be if the sum of the measures of two angles is 90 degrees, then they are complementary. And that's true. The inverse would be if two angles are not complementary. So this is the inverse. If two angles are not complementary, then their sum is not 90 degrees. And that's also true. Contrapositive. If the sum of the measures of two angles is not 90 degrees, then they are not complementary. And that is also true. And that ends our discussion for Chapter 2-3.